Yeah. Yeah. Oh. Oh, you are not going to bother me anymore. Yes. Okay. Oh, hey, ROS developers, welcome to a new live class where we are going to learn a little bit more about ROS. And yeah. So I love animals, I have to say that, but I mean, it was something personal now here. I'm sorry for that. So let's go straight to the subject of today. And today we have to work on RBIS markers. So probably you already know what it's about, RBIS. RBIS is the tool, it's a super tool of ROS that has been created in order to allow us to debug ROS programs in the robot. Before RBIS, it was horrible. It was super difficult to find out what was happening with your program, why it doesn't work on the robot. So, for example, in our case, where I was working at a humanoid company building robots, still ROS in its infant, so we didn't have this RBIS tool, and we had to build our own tools. So it was a pain because you had to build a new visualization tool for each program that you had to create. It was crazy. Now with RBIS, we can visualize what is the current status of the robot visually. So it's not by print or something that appears on the console, but in a graphical mode. And you can also visualize the state of the sensors of your programs, etc. And then figure out what is happening with your program there. So what are we going to see today here? It's about how to create some special markers. And RBIS comes with some already created markers that you can use, for example, to visualize a laser. And well, it's okay, but maybe for your specific project, for your specific program, you will need maybe something to be represented in a very specific way in your debugging loop for your program. So that's what we are going to see today, how to create your own markers, very simple markers to start, but at least you can use those in your next project, okay? So let's start. As you probably know, we are going to use the ROS Development Studio as we do in all the live classes. If you don't have an account, you should have created one. It's for free. And go to the link there and create an account. But today we are not going to wait for you to create. So you should come here with the account created, okay? Sorry for that. We are short in time. So for now, you have this account of the RDS. And now the next thing is that I'm going to share with you the code, the project that we are going to use all together here while I am explaining. Okay, so I'm going to share that project. It is inside the RDS. And so then you can follow the instructions, you can get all the explanations, you can get the extra code, simulations, whatever it is for this live class. Okay, so we are going to see in a minute. Okay, so let's go. And remember just one thing, that if you have questions at any point in time, you can put it there on the chat, on the live chat that we have there, and we'll try to answer as the class goes on. So this is supposed to be like a real class, okay, but you are located somewhere in the world, so whenever you have your question, raise your hand on the chat and say that I will try to answer to the best of my knowledge. Okay, great. So let's go then. I'm going to share with you my screen now. Let me here do some clicks so you can see. Great. So here we are. Then today we are going to use this project, and then is the ROS Developers LIVE-Class, and I'm going to share it with you with a link. So I'm going to click here on the share link, and I'm going to copy the temporary link. So remember, the links that I am sharing here with you on the live class, it's only for the people who attend to the live class. This link is going to be available for 1 day. So if you click, more or less, if you click on this link tomorrow because you didn't arrive today to the class, that's okay. So we are allowing this, but not afterwards. So this is let's say it's a prize or a reward for all the attendance of to the live class. Okay, so I'm going to copy that link and paste it on the chat. But before pasting it, I'm going to shorten it using this tool of Google, because the chat has some problems. That Google Hangouts has some problems with long links. So I have shortened it, and then let's go and put it here on the chat. There it is. So now, for all of you that have an account on the RDS, click on that link. So you can click on that link, and then by clicking there, it will automatically copy the project that you saw on my ROS Development Studio area. It will copy that to your ROS Development Studio area. So you will have the project also with the whole content. That's the amazing feature that we have in that tool. That is that you can share the notebook, the code, the simulations, results, everything. And it will be replied. So it will be executed in the same way for me as for all of you. So we can do this special class that where I'm explaining you, doing the steps, and you can do it also with me. Okay, so let's go with it. I suppose that everybody is getting the project. In case that you have any problem, let me know on the chat, okay? So let's go again. Let me share the screen with you again, and we can start. Okay, so I'm going to wait a few seconds, and then just to that everybody has the project. I am here having a coffee. Yes, very good. And then I hope that you all have the project. Okay, so if you have the project, you are in a similar screen to this one. So you should have this project, ROS Developers LIVE-Class 24. Let's open it. Click on that icon here, open project, and then open project. Great. So you should reach something like this. Okay, real JSK is indicating so far so good. Very good. So we are in business. Great. Thanks for the feedback. Now, let's go. As always, we are going to open the notebook. The notebook are the notes that we are using on the live class, so everybody can follow all the steps, and you can keep it later for later. Maybe you want to see later or do whatever. Then go to Tools, Jupyter Notebook. Here is where this live class 24 notebook is. Click on there, and then let's see what this class awaits for us. Okay, so yeah, so we are the construct, you already know, and this is class number 24. And thank you very much for the people who has contributed to this notebook, especially Efson. Warco is one of the interns of the construct, and Miguel is one of the engineers, and myself. So thank you very much to all you three. And well, what is this class is I already explained to you, is because we need to visualize some information. Okay, so you can read it afterwards, and it's a medium level, yeah, medium low. So you need to know how to manage with ROS topics, create packages, and RBase basics. So basically, okay, and then here we have a link to this class video. So once this class is finished, you can see the replay. How? Well, it's published in our YouTube channel that you can go there, but also you can watch it from here, from the notebook. If you select this tool, this cell, select, and then press the play button, then it's going to render the video. Okay, now is the video, is the live stream that we are doing now. So I'm not going to press play, but you can do it later. It will contain the final live class completed. Okay. So what are we going to do? Well, the goal is to display vital robot information in RBase using advanced markers. By advanced markers, here we mean some markers that we are creating for ourselves. And for today, we are going to use the Summit XL robot. That is a very nice robot created by company Robotics. they are very professional guys that they provide robots based on ROS. So I highly recommend you that in case that you need a robot, go there. They are also the creators of the ROS component shop. But anyway, let's go to simulations here, and then open, click on there, and then let's select this simulation of the Summit XL. Here it is, click on there, and then the simulation should start. I'm going to put it here on the side. Yeah, there is an error about the joystick and some other minor configuration errors, but actually they are not errors, just complaining. You know, they want to have everything. So, okay, so here it's something strange. Those error elements are, yeah, but those exceptions, I don't know. Okay, let's see if finally recovers, but those I don't remember those errors, so we'll see if it loads properly. Yeah, it is. So I don't know, I don't understand why those errors show there. So maybe in another moment I will have a look and see what is happening. Okay, here we have the simulation anyway. So here we have, and we are going to use this robot to apply for markers on RBase. Okay, so we have that robot. Great. So let's continue with the notebook. And yeah, one thing that we can do is to run the Teleop. It's a program, it's a ROS program that allows us to move the robot around. Let's do it, okay? Just to set the basics for all the people that is here for the first time. So let's go and open a tool. On tools, open a shell. So we can issue ROS commands, so Linux shell commands, basically. And then let's put it here. And connecting. Okay, let's see if it shows, yeah, some delays on the network for whatever the reason. Here it's coming, but in the meantime, so just let me show you that this is the command that we are going to issue, ROS run teleop twist, and is the one you can just copy from here and then paste it here. Now that the prompt has appeared, so run it there. And now once this is running, so we can move the robot using the keys that appear here, okay? Those are the keys that you should use to move the robot. So I'm going to press the keys and move the robot. As you can see, the robot is moving. Okay, let's stop. Okay, so where is the robot? Now, let me see where it went. Oh, it's still moving. Okay, stop. Okay, you have to understand that how this key teleop works, because that's what happened to me right now, and is that in order to accept the keys, you have to have the focus on the window. But remember that the focus need to have the white prompt here. Okay, so now I can move it. I can issue commands, okay? Unless you have this white thing, then it doesn't mean that you have the full focus. Okay, so you cannot issue the commands. That will happen to me because I changed the window and I couldn't say. Okay, so far so good. Okay, now let's open the RBase. That's the tool that we are going to use today, is the RBase especially. So let's open another shell here, and I'm going to put it around here. Yes, and let's copy, well, the ROS run RBase is super easy. So ROS run RBase, and waiting, something strange in the delay, but anyway, so here it goes. ROS run RBase, and there it goes. So now the RBase is being launched, or is in the process of launching now. So, but we can see nothing here. Oh, where is my RBase? Where is this window here? Where is, that's the RBase. So where is it? So it is in, it's a new window that appear, but since this is a web interface, it doesn't show directly here on your screen. You have to go to a special here tools and open the graphical tools. And by opening here, you will see that the RBase, it's here. Here it is. Okay. So we have it. Then Let me put it bigger, and I'm going to do double click here on the title, so I can center automatically the RBase window. Now I'm going to do another thing. I have included here a configuration file for RBase for this specific project. So come with me, so follow me, and then we'll open that specific config file. It's very simple. Okay, so let me show you first where it is. So let's go to Tools again. Then use the IDE. That is the program that allows us to develop our programs and also to see the files structure. So here inside the Catkin workspace, here you open that, and then inside source, I have included this Summit RBase. And damn it, because I have included, sorry. So I forgot to delete the directory with the markers that we were testing. So please, let's do one thing, because otherwise there will be no exercise for anybody. So let's do one thing. Let's just right click here on this folder and then press delete. Yes, I know it's painful, it's dangerous, because you're going, no, please trust me. This is just the exercise that we are going to do. So you have to delete it, because otherwise we are going to do nothing today. So we can go home already. Okay, I'm sure that you don't want that. So sorry for that mistake. It's, that happens. Too many things to think about. And anyway, so we have an excellent notebook and exercises prepared for you. So let's go for it. And what I was mentioning is here in Catkin source, we have this Summit RBase configuration. That is the one that I want to load. And if you come here to RBase, you must know that you can load the specific configurations of RBase. Let's do it. Let's load that Summit RBase that is here, file configuration. So for that, go to File, inside the RBase, go to File, then press Open Config. You press that one, and then we need to go to that directory, okay? That is user Catkin workspace source. So here we have home user RBase. No, we have to go one up. Then we are at user Catkin workspace source, and here it is, Summit RBase. Open it, and then yeah, you can discard the current configuration. And there it is. So now it is showing us all the configuration that I have included in that RBase configuration file. And what is showing basically is the laser scan of the robot and also the robot itself. As you can see, is the robot showing all the environment that is here. So it's in front of this, and then it's detecting some stuff around. Okay, so so basically that's it, what you have. Okay, so far so good. So let's continue then. Let's go to the notebook again, and here it is. So let's see the goal. What is the goal? Okay, the goal is that to be able to do things so amazing like this one. Okay, so we are not going to work today on that because that's a lot of work, but we are going to start with the basics. That's why this class is how to create basic markers. Okay, so but you can do this is an actual recording of an RBase window. So this is real stuff. It's not composer thing that we have done with Photoshop or something like that. It's not that. Okay, so the purpose is to visualize that meaningful information on the screen, so you can see what is happening with your robot and what the robot is expecting, what your programs inside the robot are expecting. So how can we do that? Well, let's start by using basic RBase markers and pictograms in RBase. So those are the two ones of markers that we are going to see how to create them here in your own programs. Okay, so you will have to create in your own ROS programs, you will have to create RBase markers or pictograms and publish them into a topic. Basically, that's it. So in your ROS program, the program that controls your robot, you had to add some special code for creating the marker with the information that you want to be shown on the RBS. And then you publish that into a topic. Then you come to RBS and select to add, and then you will add those type of markers, and the information will be represented there. Basically, that is the process that we are going to follow. Okay, so you are going to see very clear with an example. So don't worry if you don't understand. So let's create a basic RBase marker. Okay, so for that, let's start. Let's go to the one of the shells, for example. Well, this is the RBase. Let's not close it. I'm going to use the one of the keyboard, so I don't need it. So I'm going to do Control-C. If you don't want to do that, you can open a new shell. Going here to Tools. Okay, I don't want to have everything super populated there. So let's go here. We need to create a new package. For that, we need to go to the Catkin workspace. Remember, where is the IDE? Let me see. The IDE is here. So remember that we have in the ROS Development Studio, we have several workspaces, okay? And here is a file that has been included also. You can delete it because we don't need it. Obstacle, avoidance, example, XML, you can delete it, okay? Something is rubbish, that. So we have several workspaces. One is for the simulation. So wherever you have simulation code, you should put it there. Another one is for the notebook that contains our class notebook or any other notebooks. And this one, the Catkin workspace, is for containing code, ROS code, any ROS code that is beside the simulation. So it's the code that will be executed on the robot. So you will put it here in the Catkin workspace /source. And here we have another one that we'll see in future live classes, that it's about results while training with machine learning. You will get the results there of the reinforcement learning algorithms. So let's go to the Catkin workspace here. CD, Catkin workspace, and then source. So now here on the shell, we are at this level, okay? So if I do an ls, you can see that we have the CMake list and the summit. Let's create the package. Please use the same names as I am indicating here, because otherwise some things may not work on the demo because of the names. So Catkin, you know how to create a package, don't you? Sorry, Catkin make, no, sorry. Catkin create package. Then let's call it my RBase markers. And then it depends on ROS-Pi. So let's include that as a dependency. Great, so we have it. And then if we go, for example, let me move this a little bit like this, and I can click here on the IDE. You see now that here is our package created. Great. Now let's go inside and create a basic marker. Well, but before that, okay? So what is the type of information or message that we are going to use to publish the basic marker, okay? This marker that will contain some data. So this basic marker, we need to create, as you know, we need to publish into a topic. And what is what we publish into a topic? Well, what we publish is a message. In this case, we have to publish a special message that is called a marker. Here, a marker. So this is the message that we have to publish in the topic that later will be used by RBase to visualize the information. Okay, so this is the type of message. You can, if you want to see the information, the structure, you can do this on the shell, this command ROS message info. By the way, so let's do ROS message info, and then we'll get this, having some delay here. Yeah. Okay, so here we have, and well, it contains a lot of information. This is the structure of the message, and we are going to populate this information in our program with the information that we want to be plot on the RBase. Okay, so let's start here. And yes, so for this, let's create this basic marker file inside the source directory of the package. So here you go to, let's use the IE, okay? It's easier. It is here. It is more graphical to be shown there. So let me put the ID here on the side and a little bit larger. And here, inside the RViz markers, inside the source, let's create a new file. Right-click, new file, and call it like it's said here, basic marker.py. So basic_marker.py. And then open it. It's empty, of course. Now, let's start by doing the basic thing. So let's copy and paste this structure here. Copy and paste on the basic marker. What does it do? Well, the typical Python declaration, then we import ROS_py, and then we import the marker message type. You know, is the marker, this is the message that we are going to publish. Then we go, also we need the point, we'll need the point message because we'll need to put it inside the marker. So that's why we are including it. Now let's go and create the basics of the marker. How do we create the marker itself? For that, we are going to create this class, marker basics. So you can copy this. This is the structure of our class. You can copy and paste it here beneath the previous code. Okay, so it contains 3 functions, and we are going to be one by one. This is our style. I mean, this is not mandatory to do it like this. This is a way that we have found to be easy in order to create the markers. Okay, so but there are many other ways of doing it. You don't need even to use classes, but that's the way that we are going to do. So let's go on the init function. Let's use this code here. For defining the init class, you can just copy the code that is here beneath the init self 2 dots. So Control-C and substitute the path by that code. And let me increase here the size of the letters, and also a little bit here so you can see better. Okay, just be aware of this indentation. Okay, so for that code that is not properly indented, please indent yourself. So what is this init doing? Well, basically, it's creating first the publisher. The publisher is the topic on which we are going to publish the marker information. So this is a typical publisher. Then we define a rate, and then an init marker function that you are going to see later. Okay, actually that is here. So we are calling this function here as the init marker. Okay, so this is the init function. Basically generates the topic and then calls the init marker. Let's go and see what the init marker does. So it's all this code here. So you can again copy this, select it up to here, and then Control-C and substitute here the path beneath the init marker function. Okay, so again, beware of this indentation. You see that the whole code after the first line is not properly indented. So you can do one thing. Let me do it in one single screen so it will be easier for you. So select the whole code like this, and then press Tab. Then automatically all the code will be indented to with the same indentation. Great. So what do we have here in the init marker? Well, we create a marker object that, as you remember, this is the message that we are going to publish, marker, okay? Then we indicate this information that we are going to publish on the marker, from which frame is being published. So it means, this frame ID means from which frame the information that the marker contains, it is relative to. For example, if we say, oh, there is an obstacle 2 meters in front of the robot. Okay, 2 meters, but measure from which part of the robot. If it is from the center of the robot, it's not the same as it's from the back of the robot, for example. So it's different because the robot can crash before in one situation than in the other. So it's very important that you indicate from which frame. Okay, then we create the header, the time, then a namespace that you can group different markers in namespaces. Then we put this one, not in very detail because it's not important. This is the index at which we start, because this has to be consecutive publishing in the index. And then here we indicate the type of the marker. As you have seen here on the shell, if you open the shell again, where we look for the information of the message. Here, remember, we look for the info of the message. Then at the very beginning of the message, it contains a list of definitions. And every definition of this, it's a type. It's a type of marker that you can plot. So you can specify that this marker looks like a sphere, or you can say like it looks like a cube, it looks like an arrow here. So it depends on you how you want to represent your information. You can specify here type. And then the action, you can specify also the action to add this marker to what is already being represented, to delete, to modify what is already represented, etc. And here. Okay, so basically you can do all those three options: add, delete, or modify what is already there. Then what else? So what this marker contains, it's a point, and the point is the location at which we are going to represent that type, that sphere. Okay, so that is why we imported here the point. So this marker basically contains information about a point. So imagine that you want to specify the location of a person that you have detected. Then you can create a marker that indicates, oh, with a simple sphere, you can do it, or with a cylinder. And then you will publish this marker at the distance from the odometry frame at which you think that the robot is seeing a person. Okay, so, and where do you code the information of the position? Well, you code it inside a point. Okay, in this case, we are just assigning to the point, we are just assigning the Z value. That is a 0 value. Okay, so this is just an example. So we're indicating that everything is 0, and in this marker we can change the Z value when we call this init marker. Okay, so we can change only that position. Then once we have the point at that Z position, then we assign to the marker position. Also, you can indicate the orientation, the scale of the marker. So you can change that. Also, you can specify the color in RGB code. Okay, and then so once you have all this information coded for that marker, remember that this is the marker object, then you also can specify a lifetime for that value, for that marker. And if you specify 0, then it means that it's not going to disappear. So it's going to stay there until you delete it, or you don't want to be shown again on the RBIS, for example. Okay, so that's how we construct the marker and how we include the information in it. So you can modify the information here based on your program. For example, the location, you can get, here is a very hard-coded value, but you can get this information from another module of your code that is the one that is detecting people. So you can set the point values at the location that you detected the people. Okay, so let's start and let's almost execute here, because we have to finish this function and we are almost there. So let's go here to the start and copy this code here. Copy and substitute the pass function. And remember that those two last lines are not properly indented because this is a while, so we need an extra indentation. Remember that, okay? Please, because otherwise then when we execute it, you are going to have some problems. Okay, so well, basically this start is just a loop that is publishing the marker, the self-marker object that we have constructed here, this self-marker object, and we have populated. So it's being published at a rate of 1 hertz. Remember, this rate is created here at 1 hertz. So this marker is going to be published continuously once the start function is being called. Okay, so how do we call that function? Well, let's create a main, and let's create a main and call the start. So for that, copy this code here. You can copy everything and put it beneath here. But remember to go to the very beginning of the editor and paste. Remember, that was the class, and now we are on the main of the Python program. We are outside of the class, of the Python class. So yeah, you have to be very careful with all those things in Python, because Python is very sensitive to the indentation. Okay, so it's how it works, Python. Okay, so what it does, this main is just initialize the node. So this is going to, the whole program is going to be a ROS node. And then it's going to create a marker basics object. Marker basics is the class that we have created here, okay? The one that creates everything. By creating that class, the init will be executed, and by executing the init, this will be executed, that is this class, this function here. Okay, so the marker will be created, but still not published. Okay, so afterwards, what we are going to do is to do call to the start function. So we have this code that has been, this class that has been instantiated, and then we call its start function. So then it will start publishing. Okay, we got it, guys, we got it. And here you have the code of everything together. So how it should look. And in case that it doesn't work for you here, this construction, you can just come here and copy everything and with the proper indentations, and it will work. Okay, so let's execute it. Then first remember to save, because it's, if you have here a dot, it means that you can have some still some changes. And then we, after you have saved, let's go to another shell and execute this code. How do we call it? Well, ROS run, name of the package. Our package was called my_RBIS, whatever markers, and then the code, the Python executable, basic maker.py. So you launch it, and then it's going to show nothing because we didn't put any details. And here it looks like there is a problem here. Oh, okay. Okay, so yeah, so there is a problem because there is not included here the image that you should see. For some reason, okay, is missing. Okay, well, anyway, we are going to see how it looks. Then, so let's continue, no problem. Here we have launched the program. Let's go to the RBIS, okay? Go to the RBIS, and here you can see nothing. You can see nothing here. What is there? Nothing is there. So what can we do here? Okay, so what is happening is that this program is publishing on a topic, the topic that we have specified here, marker basics. But then we have to include that marker here in the RBIS in order to be able to watch it. So let's go and let's add it. Okay, let's add. Then let's go and look into this list that appears here. You have to look for the one that says go down, 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 and then it says marker. Here is the one, select that one, okay. And then here beneath the laser, a new marker has been included, but still you cannot see anything. So where it is my marker, I want to see, okay, no problem, just wait a little bit. So don't be so impatient. So come here to the marker, open it, and let's configure the marker topic. It has visualization marker. This is not our topic. Let's click here and select marker basic and press enter. then we should get this blue marker that is our marker. Okay, so you should see that one there. Okay, so now this is the marker that we are publishing on that topic, and that's why we are watching it there. You can do some small modification, well, or not small. For example, let's say the scale, for example, this scale is too big. So I'm going to say, instead of 1, I'm going to change to 0.5. Yeah, everything. So it's going to be 0.05 and 0.05. And the color, I'm going to put a little bit of red, for example. Oops, sorry, I pressed wrong button. And 5, for example. And then you save it, kill your previous code, and then execute it again. Now, if you go to RBS, then it should show differently. There it is. Well, it's very small now. It's very small. Okay, so you can see that in this case it was very small, too small. Okay, for my taste. Okay, and this is because this is being published respect to the odometry frame. So if you add here another frame, let's add a frame. So click on add and look for frames here. Sorry, axis. Look for axis and then select the axis. And then, well, basically it's already configured there for the odometry. But if you come here to the axis and select which axis is the fixed frame, that is the fixed frame is the odometry in this case. Is the one that is configured here. Okay, fixed frame, it's odometry. That is why it's showing odometry. But we can say that we can configure that smaller. So let's say 0.2, for example. And there you can see now our marker there. Okay, so far so good. I hope. Okay, so Yuan Yao, he's saying that you should execute the cell again in order to see the image. So I don't know why it's not being shown in my case. Basic marker. Okay. Oh, okay. Yeah, so that's strange. That's strange. Okay. So anyway, let's continue. If you don't have any problem, let's continue and use the pictogram. This is a different type of marker. This is something different. And in this case, we are going to use this type of message that is called the pictogram. And the pictograms basically are icons. So you can use icons at your will that will mark some position, some location in your environment with that specific icon. So you can get a clear look of what is there. Okay, so what we are going to do is to create another code that will show us how to create this marker. Okay, so let's go and let me see, because here we have the code. Yeah, so we have all the code here. In this case, we don't have it separated by functions. So what I'm going to do is to copy everything here into a new file, and then we are going to go step by step. Okay, don't worry, I'm going to explain you everything. So let's go now to the IDE again and create another file here inside the source, and let's put the name pictogram demo.py. Okay, so come here, source, right click, new file, then call it pictogram demo.py, and let's open it. Then go to this cell that contains the whole code and select everything. How can you select everything? Control A selects everything, then Control C to copy, then come here to the IDE, Control V. And here we have everything with the proper indentation, and then save it. Okay, so far so good. So we have now another program there. Great. So what do we have here? Well, apart from importing some important stuff here around that is necessary for the code, what we have now is the pictogram and the pictogram array messages that are imported from this package, JSK RViz plugins. And then, well, we have this callback, go callback. Why do we have this go callback? Because we want to do something special with this example. In this case, we want to show the markers every time that we send a new goal to that topic, robot goal. A goal is a position, it's a point in 3D coordinates that it is supposed to be the goal where the robot has to go. Okay, so every time that we publish something on robot goal topic, then this callback will be executed. And then this callback, what it's going to do is to publish the message from, no, wait, sorry, I'm mistaken. Okay. Yeah, okay, the publication, let me see, where is it? The publisher is here, and the P, where is the publication? I cannot see it. Oh, here it is. Okay, here it is. Okay, yeah. So, yeah, when we get this topic here, a new goal, what we are doing is to get the current position of the robot. That is what we are getting, the current position, and then we are going to use this current location to configure one of the locations of the pictogram. So we are going to show on that location where is the robot itself, and then we are going to use also the goal of the robot. That is here is the destination. Yeah, the destination here, and yeah, so that's the current location, exactly. That is the current location. And then we have the current pose. That is the one that is obtained by the odometry. So we are going to show two images there. One that shows the current location and another one that shows the current destination. I said the other way around. This is the current location and this is the, oh yeah, no, this is the current location that is obtained from the odometry, correct. And then this subscriber, let me see. Okay, so this is, okay, sorry, I need more coffee. So this is the destination. Okay, yeah, so the destination is the point that we are sending through the robot goal. Okay, so this is the destination where we want the robot to go. And then the current location is the position of the robot that is obtained based on the odometry framework. Okay, so we don't have any navigation here. So every time that we call this topic, we publish a topic. I mean, here we publish in this topic a new goal. Those two variables, destination and current location, are going to be set. One with the current position of the robot and another one with the point of destination. Okay, and this is the information that we are going to use later to create the pictogram with the proper information. Okay, so based on that callback, we initialize the node here. Then here we create the current location that equals destination, and it's an empty point, so it's going to be published by default at 0. Then we have the publisher. This publisher is the same as in the previous example, is the topic at which we are going to publish our marker, our pictogram array. And then here the goal sub is the subscriber. This is the topic, as I mentioned, that is going to provide us the point, the final point. Then we have array, and then the pictograms array. Okay, so it's the location where we are going, and this the current position. Okay, so then we have a while loop that is going to be repeated all the time, so we can keep publishing that information in case that something changes, a new goal has arrived. And then what we are doing is to create a pictogram array. With a pictogram array, we have the advantage that we can publish several markers at the same time. So it's not only a single marker. Okay, so what we are going to do is to create two messages, pictograms. In this case, we have a for loop for creating it, and it's based on this array that we have created here. So we create one message of the pictogram here, and then we populate that message. The structure of this message is basically more or less the same as in the previous case. You can do also the same command here. Let me see where it was. Here, this command, and you will see the structure of the pictogram array. But you will see basically that is the same as the previous example. Then you have to specify the frame ID. It means the frame at which the point information is being published from. And then the action, in this case, the action is a jump. So the pictogram is going to be jumping on the screen up and down. Then, well, if index equals 0, yeah, so then this is just a trick in order to indicate which position we are going to include into the pictogram. So either the current location or the destination, because this loop has two loops, two repetitions, one for the current location, another for the destination. So basically what we are going to do is to fill the message post position with the current location, or if it is the second case, for the destination. Then what else? So in this case, we are indicating here the orientation with several indications of the orientation of the icon. That means the look that the icon is going to have on the screen. Then the size of the icon, and then the colors. And also, so this character, that the character is, let me see where we have it. It's the character is the one that we have defined here in the pictograms, okay? So it's the character that we are going to use, one for the current location and another one for the destination. Okay, so we fill that in that case, and then we include every message in the array of pictograms. We append that in that array. So when we have constructed this for two pictogram messages, then we have an array with two elements, then we are going to publish that array. And then we rate the slip and repeat. So basically that is the code that we are going to use. So remember to save it. And now let's go and open a new shell and launch it. Let me see that I don't get any, that I don't miss any information. So here you open a new shell, and then let's launch it. This one that is called Pictogram Demo. So if you do a ROS run again, it's called my ROS markers, and then it's the program is called Pictogram demo.py, and then you launch it. Okay, so the program doesn't say anything again. So let's go to the RBase that is around here. Oh, and we don't have anything here, neither. Oh, I went too far, just a second. Okay, so what is happening? Well, it's happening basically the same thing as before, that we need to add a specific marker display in order to be visualizing our information. So come here to add, and then go and look for one that is the pictogram array. It's almost at the beginning of this pictogram array. Remember, that's the message that we are publishing, pictogram array. So select that one. Okay. And then it takes a while to show and to be configured. I don't know why, but if you see that, don't worry, because it's configuring. So for some reason, it takes a while. Okay, so it's done. Now you can see that we can see nothing here on the screen again. So let's go down and select here pictogram array, double click and go down and select the topic. So now we have to include our topic, pictogram array, and press enter. And now you should see here something blue there that you can get close. And basically what we are seeing here is the default location that is 00 for both pictograms, the current location and the destination. Those were the basic values. Okay, so let's send a goal to the topic. Remember that we have a topic here, robot goal, that we can publish a topic. Let's do it and let's see what happens. So get open here the RViz so you can see the difference and select a way, I don't know, some view that you can see both things. Let me remove like this and separate a little bit. So I'm going to open another shell and publish on that topic. So how do we do that? ROS topic pub on the topic that was named, I don't remember, it's called robot goal / robot goal. Then let me wait until the prompt appears because I want to autocomplete everything. So I don't know what is happening, but it's still going very slow, this. Okay, so ROS topic pub, robot goal, then do a double tap. It's going to show the message point and then the message. Okay, so these X, Y, and Z are the distance at which you want the robot to go, is the goal, okay, so that we want to show. So let me put the goal at X, let's say X1, 1 in the front of the current location of the robot in odometry frame, remember, in odometry frame 1, and then 2 on the Y axis. So before I hit enter, let me switch again to RViz so we can see the change. Okay, so once you have this configured, hit enter. And what happened here? ROS topic pub, what? Okay. So I did something wrong. Let me repeat it. Oh, yeah, so I see. There is an error here. Instead of pub, I wrote 1. So pub here. Okay, let me send it. And then it's publishing. Now we have this change, as you can see. So one of the icons is on the robot itself. So it's at the proper location, current location of the robot. And another one is at the goal that we have indicated. You remember 1 in the red axis and 2 in the green axis. Okay, so here, yeah, you cannot see very well, but basically that's what is showing. Okay, so, well, there is a small change here. I cannot see that. It should be more on this corner here. It has some error here. Okay, we should investigate what is the error of the location, but it's not important because you get the idea. Okay, so you get the idea about how this works. And basically that's it. So that's the example that you should see, and you can move the robot now. You can move it and you will see that the icons, they remain there. You can repeat publishing on the topic and you can repeat that, and then you will get again to move the 2 icons. So this is just an example about what you can do with these markers. Okay, so on the next class, we are going to see some more interesting configuration, more advanced configurations on the next class of the next live class. So if you want to learn more about that, we have a special course here that is called ROS Rviz Advanced Markers. And this course contains a lot more of information and very, very advanced markers that recommend you to have a look, in case that's in our online academy that is called the Robotic Night Academy, that you use, simulations of robots in the same sense as here, but it's guided, it contains so many guides, more detailed than what you can see here. In case that you are interested here, remember that you have a 15% discount, but it's only valid until tomorrow. Okay, so only for you that are attending. Okay, and then let me remind you that if you want to learn more from the experts, in a week time is going to close the time for buying a ticket for the ROS Developers Conference. That's an online conference, so you don't have to travel. And we have invited many experts that are going to be talking about their specialty in ROS, and they are going to show you how to do the things about humanoid robots, about state machines, about robot navigation, many interesting subjects. So if you want to attend, remember to visit that webpage and get a ticket soon. Okay, and that is all. So the next class is going to be about more dynamic markers. So let me stop here and let me know if you have any question on the chat, and I will have some minutes here for answering your questions. So that's it for today. One thing, remember that if you liked the class, please give us a thumbs up, because that's the way that we can know that we are doing okay or not. And if you think that is not, just put a comment beneath the video once it's published. It's going to be in some seconds, it's going to be published. So give us some feedback and, hey, this could be improved like that or like this. And that's it, basically. So let me know if you have any question on the chat. I'm going to stay here for a couple of minutes more. In the meantime, we can see, so there are no more mosquitoes here. So I think that my fame has been moving around the mosquitoes community. Well, I hope that it's going to be like that for the rest of the summer. Anyway, so I see that there are no questions. People is still there, but I have no questions. So I suppose that everything was so clear. Yeah, well, the subject of this class is not, it was not very complex, you know, because basically you only have to know how to create topics and how to create a message to be published into a topic. And basically what we have done is that, nothing more. So I see no questions there. And so we are going to stop here then. So guys, it's been my pleasure to meet you all here again. Remember, the next class is going to be about more advanced markers. And I hope to see you all soon around here. Thank you very much, and subscribe to our channel. One video of ROS every day. Remember, one video of ROS, okay? So subscribe to our YouTube channel and get this information. Bye, everyone on the chat. Bye.